Hello everyone and welcome to this lesson. Today we're gonna talk about vectors and scalars. Then after describing them, we will move on to addition of vectors. We will learn how to do the addition of vectors and how to get the resultant vectors of two or more vectors. Let's start. So let's say for example we have these two lines. Or actually before going here, let me describe something. What's the difference between a scalar quantity and a vector quantity? So basically a scalar is a number which express a quantity alone. Like let's say for example when I say my weight is for example 80 kilograms, I don't give any direction with this. And some of the examples for scalar quantities are like mass or energy, money, volume. I don't have to give any direction. Like you don't say $5 with degree of 30. We never hear this. So this is technically like the difference between scalars quantities and vector quantities. Whereas vectors, when I vectors quantity, when we talk about them, we have to give a direction. We can't just say the magnitude or the quantity itself, because this information is not enough to describe what we actually want to describe. For example, displacement or velocity or acceleration. Like when I say for example I traveled a displacement of let me say from this point to this point. I started here and I walked all the way here. This was my displacement. Okay, but when someone hears this, they want to know the direction. So I can't just say I traveled for example 200 meters alone. I have to give a direction. So in this case my direction was at the angle 0, or I can say at the positive x direction. Okay, let me change this pen. So in this case my direction was the positive x direction. So now we learned that there are some scalar quantities and some vector quantities. Lines, such as this line, I describe it as just a line, and when I describe it as just a line, I don't have to give a direction as well. But this, which is the vector b, when I give information about it, I have to give the direction as well, which is, as you see here, in the positive x direction, or at the angle 0, which is at the right x axis. Okay, so let me write here for example scalar quantities and vector quantities. So can you think about something like scalar quantities? Some of the things that are on my mind right now, maybe mass by kilogram or by gram or whatever. Okay. Second thing is for example volume. We don't give a direction when we say a volume. Like for example a cube. You don't give you don't say 3 meters square at the direction of north or south or whatever. We don't say this. We just give the scalar itself, and that's it. Energy or money, as I told you. Maybe what's else? Maybe even the sound or something like this. Okay, now for vector quantities we give displacement. maybe velocity, or even acceleration. So these are scalar quantities and these are vector quantities. Now you learned one thing, that vector has a direction, is a quantity with a direction. When you speak about a vector, you have to give the direction by angle or by saying north, south, or whatever. Just describe a direction of this quantity. Scalar, you don't have to give any direction when you talk about scalars. Now, the second thing I want to talk about is how to add vectors. Now, there are many ways to add vectors actually. Let's, for example, say that we have a vector in this direction, which is like, basically let's say that it is a force that's pushing in the right direction, and let's say that it is like 100 Newton, and another one in the same direction that is, for example, 400 Newton. Okay, F equals F1, this one F1 100 Newton and F2 400 Newton. So how to add these? So basically, because they are in the same direction, which is the positive x-axis, we're just gonna add them together. So Fr, or the resultant force of these two vectors, will be 500, which will be basically a longer one. Like, it's not for scale here, but like, since I'm gonna write, like, if I'm gonna write the, what do you call it, the quantity, which is like 500 Newton, it doesn't have to be like for scale. Whatever, don't like pay attention for what I just said here. So Fr, basically, you're gonna hear me saying this word, resultant vector, or like resultant force of all the forces, or all the vectors that we have. So in this case, the resultant vector of the two forces, or the two vectors that are given, is 500. So Fr is basically F1 plus F2. But you know what? Keep this in mind. When we add vectors, we have to add the x components, then the y components, each separate. You will see what I mean by this. Now let's have a similar example. Let's say that this one, F1 equals 300, F2 equals like maybe 100. Then this one is pointing in the negative x direction. Okay, F3 equals maybe, let's say, 150. Okay, now the question says that I need to find the Fr, or the resultant vector of all these. Okay, so how am I gonna find it? I know that these two are in the same direction, which is the positive x-axis, or in the right direction, but this F3 is pointing at the left side, or in the negative x direction, so it has to be negative. So Fr will be F1 plus F2, which is because it is pointing in the same direction, minus F3. Why? Because this one is pointing at the other direction. Okay, so this will lead me to Fr equals 300 plus 100 minus 150, which equals to 400, 300, 250. Fr, 400 minus 150 is 250. Okay, so now we learned how to measure, or like how to find the resultant vector of three vectors on the same axis. Basically, you have to pay attention to the direction when you add them. Now let's move on. Okay. And okay, let's try something different this time. Let's say this one, f1 equals 150. Then we have f2 equals maybe 90. And then we have here f3 equals 80. Okay, in this way, how to add them? So what happened here, that we have to find the x and y components of each vector first, then add them. So if the question says that find fr, okay, how to find it? In order to, like, the rule is basically of fr is the x, the, how to say it, like the force that's acting in the x-axis of all the forces, okay, the force acting in the x-axis of all the forces plus the force acting in the y direction of all the forces. Okay, so what you have to do is you have to find f of x and f of y first. Okay, how to find these two? What do we have here? Based on the direction given. So you all know that, like even for those who don't know, we have that this is the angle system. This one is like the 0, like x minus x, y minus y, okay? We have that this one is 1, or sorry, 0, and like goes on. This one is 90, this one 180, this one is 270, then here we have 360 again. So basically I'm using, like, based on this like what do, yeah, like the xy components, that's how I can find the f, x and y. So I have that the for f1, okay, for f1 what is the x component? So f1x equals, f1 is pointing at the right direction, or like at the x direction, so it has an x component of 150. Okay, okay, how about the y component of the first vector, or the first force? I don't have it because it's just pointing at the right direction. Okay, so in this case it is 0. Okay, for f2 same thing, I only have power pointing at the right direction, which is basically the x direction. So what we have here is 90. But how about the y component of f2? So f2y equals, I don't have anything pointing upward or downward, so it's gonna be 0. Okay, how about f3? For f3 I don't have anything that's like there is no power pointing like at the x direction, whether positive or negative. So fx will be 0, f3x will be 0. How about f3y? So f3y in this direction, in this situation here, we have that f3 is pointing upward and it is 80. If it was pointing downward, it would be like if it was pointing that direction downward, it will be minus. Okay, the fy will be minus. We will see that in later examples. Okay. In this case, we have the 80 pointing upward, so it is 80 and positive. Okay, now what we have to do is basically f1x plus f2 or f2x plus f3x. Let me put this in a rectangle so you don't mistake it. Okay, now for this one we have to add f1y plus f2y plus f3y. Okay, so now you'll have fx equals, let's add them. What do we have? f1x is 150 plus f2x, this one is 90, plus f3x 0. Seriously? Okay, 240, sorry. Now fy is 0 plus 0 f2y, because both of them are pointing like they don't have any forces in the y direction, okay, in the y-axis. But f3, it has a force in the y direction, which is positive. So directly fy equals 80. Okay, now we have to write this, or like find fr. So fr equals 240 I plus 80 J. Now, what are the I and the J? Okay, look. Let's say that this is the x, y, z, okay? Basically the three-dimensional block, okay? Let this be x, and this be y, and this be z, okay? So basically you just have to memorize this. Like, you can understand it, but like there is nothing to understand in it actually. You just have to memorize it. So when we write it in terms of vectors, you have to add these letters, because fr is not actually just like the addition of these two. Fr right now is basically a vector. So whenever I write it, I just write the word vector, or like as a shortcut just v dot, okay, so that I remember that this is a vector. I can't just add 240 plus 80 and get fr. No, fr is 240i plus 80j. Again, fr is 240i plus 80j. This is how we write it. Like, this is the final answer, okay? Why? Because basically right now I can represent fr by following these two. How? Let's say that I have here the xy plane, okay? The x, which is the first one, okay? Let me just follow it. Let's assume that this is 100, and this is 100, this is 300, so this will be 240. It will be here. We have again 100 and 100, so 80 will be somewhere here. So these points have to meet here, okay? Fr will be from here to here. This is Fr. So basically Fr and this thing here is Fy, and this one here is Fx. Okay, so look, right now fr is not actually the addition of this one plus this one. If I want to find fr, I need to use the Pythagorean theorem, okay, in order to find the real magnitude of fr. But fr does not equal the addition of 240 plus 80. There is no such thing, okay? So that's why, just like, so that you don't misunderstand it, just like I highly advise you to write the letter V or like the word vector in front of any vector quantity when you find it, because it will make everything clear for you and you won't make mistakes, because I've made a lot of mistakes of this. So like I highly recommend you to work with this advice. So let's go back to what is the ij, and in the future we will have k when we will study 3D vectors. So basically, when we write any vector, like which is made of many vectors or like more than a single vector. For example, if R here is made of two vectors, the first one is 240 in the x direction and 80 in the y direction. Okay, so basically some of you are just saying now we can just like write x here and y here instead of writing j and I. This is basically correct, but this is how scientists do it. It's not my business to decide this. So we're gonna, like, whenever we're gonna write vectors, we're gonna use the letter I for the x, j for the y, and k for the z. Okay, and k we will use it, I told you, when we have 3D vectors. So now we found fr, we found what is actually needed in the question. Okay, now let's say if they actually wanted us to find wait a second, yes, we have to find the angle of fr, because fr has to be a vector, and vectors have to have like a direction with them. So what's the direction of fr? So basically the direction we're gonna give it by finding this angle here. So how to find this angle? We have the rule of tan theta equals the opposite over the adjacent. So fy over fx. Okay, which equal to, now we don't have tan theta because we don't know theta. So this will lead us to tan theta equals tan inverse of fy over fx. So if you're wondering how this happened, we don't have this theta, we are actually want to find the direction of fr. Okay, so we know that tan this theta equals the opposite over the adjacent. So we can say that theta equals tan inverse fy over fx. Basically we're gonna take this one down, okay, or let's say that we're gonna divide all this equation, we're gonna divide it by tan. Okay, tan only, not tan theta, only tan. So what's gonna happen here is this one is gonna be deleted with the other tan, and this one is gonna be divided by a tan, or basically this side, and when we rise it up, it's gonna be tan to the power minus 1. Okay, which is basically tan inverse here. So now let's find this. Tan inverse, what was fx? Fy. Fy was 80 divided by 240, which is fx. 240 equals 18.4349. So 18.435. So theta equals 18.435. 0.435. Now we found this angle as well. What do we need more? Let's say that in the question was given to find FR, like the length of FR. So in this case, we need to use the Pythagorean theorem to find FR. So when I'm gonna write this FR, you notice that I'm not gonna write the word vector in front of it, because actually in this way, like FR, like let me say this way, I'm just gonna use the Pythagorean theorem to find FR. So FR square equals fx square plus fy square. Okay, so this lead me to FR equals to under the square root fx square plus fy square. So let's find it. 80 square plus 240 square equals 252.98. So this is right now the actual length of FR. So FR equals 252 point, let's just make it point, yeah, okay, 0.98. Okay. What do we have here? Yeah, it has to be in Newton. Actually, I didn't give any unit, so no need. Yeah, just 252.98. Now, what we learned what's the difference between vectors and scalars. Okay, difference between vectors and scalars, that vectors is line or like a quantity which has direction with it. Scalars doesn't have to have any like direction. We learned that how to add vectors or even how to subtract them when they are in opposite directions, like just we saw here. These two are pointing in the right x-axis or in the positive x-axis, whereas F3 here is pointing at the negative x-axis, so it has to be subtraction. Okay, F1 plus F2 minus F3 because it's in the other direction, and we get the result. So this is basically the addition of vectors. And here we learned how to add vectors which are like not on the same axis, on the different axis. So in this situation we learned that we have to find the x component first of each force or of each vector and add them together. Basically, for example, fx and fy, we add them all together, then we put them in this equation. And remember, in this is not the, what do you call, this is a vector. So basically the addition of those does not give me FR. No, actually it is just like a way to represent a vector quantity, and you recognize this by the letters I and J. If you actually want to find FR, you need to use the Pythagorean theorem. 240 like under the root 240 squared plus 80 squared, all under the square root, and you will get this answer. Okay, and yeah, when you write any vector you have to give the angle or basically the direction of it. And thank you for watching. If you like this video, maybe you can give me a like. This is actually my starting on YouTube. Thank you.